Hello Internet, it's Kim. Today in this video, I am going to show you how to make soap. Soap is simply the saponification process between some kind of oil and a strong base. The oil used can be anything. It could be some kind of animal fat or even vegetable fat. So in this case, I'm going to make soap using bacon fat. In this project, I am using sodium hydroxide, which is highly corrosive and can severely burn your eyes and skin. Anytime that you're working with hazards, wear the proper personal protective equipment, such as safety goggles, gloves, and old clothing. Also be mindful of others and pets in the vicinity and take steps to minimize accidents.
Oh, just look at her. She's so cute.
To start things off, I need to extract fat from bacon, which is arguably the most delicious step in the entire process. I may have slipped a couple pieces to the dogs because
How can you refuse those faces?
to try to obtain the cleanest fat possible, I baked the bacon by placing it on an elevated rack on a tray so that the fat would drip away from the bacon. I then transferred it to a frying pan at high heat to ensure no water was left in the fat. Once the fat wasn't sizzling anymore, I was pretty confident that the water was gone. I filtered the fat through a coffee filter to remove any bits that were left behind. I ended up isolating 91 grams of bacon fat, so now I need to determine the amount of sodium hydroxide I would need to react with this amount of fat. Here I am showing a cartoony version of the saponification reaction, which is the reaction that gives you soap. Triglycerides, which are the dominant type of molecules in fats and oils, has a glycerin backbone, which I am showing in orange, and 3 fatty acids attached to it, which are in blue. The saponification process cleaves the bond between the glycerin and the fatty acids to give 3 fatty acid salts, which is what we know as soap, and 1 molecule of glycerin. There needs to be 3 strong base molecules in this process, 1 for each of the bonds that are being broken. If we know the molecular weight of the triglyceride and the sodium hydroxide, we can easily determine the mass of sodium hydroxide that we will need for 91 grams of fat using stoichiometry, which is a type of calculation taught in high school chemistry. See, Jimmy? You do use the skills learned in high school in real life. The molecular weight of sodium hydroxide is 40 grams per mole. However, determining the molecular weight of triglycerides can be a little bit tricky. You probably already know that there are a variety of different fats out there, and the main difference between them is their fatty acid composition. Mainly, the 3 blue legs are different depending on the oil you use. Luckily, the fatty acid content for most oils is well known, and I just looked up the fatty acid composition of lard on Wikipedia as a good approximation. I selected a percentage composition within the range given. Using the molecular weights of these fatty acids, I was able to calculate the average triglyceride molecular weight in bacon fat to be 860 grams per mole. Now I could use stoichiometry to calculate the mass of NaOH needed. One thing to consider is that most soap recipes use an excess of fat to avoid accidentally having leftover strong base, which could dry out and irritate your skin. Normally a 5% excess of fat is used, which in the industry is called a 5% superfat. Do-do-do-do, With a 5% superfat, 12 grams of sodium hydroxide is needed to react with 91 grams of bacon fat. The last thing to consider is that the sodium hydroxide needs to be dissolved in water to react efficiently with the fat. A 30% solution by mass is standard in the soap making industry. It has enough water to completely dissolve the sodium hydroxide, but there is not too much water to prevent the soap from emulsifying, which is called trace, and solidifying. When sodium hydroxide is dissolved in water, it releases a lot of heat, and so sodium hydroxide should always be added slowly to water, and this should be done in an ice bath to keep the solution cold. In this beaker, I am adding the 12 grams of sodium hydroxide to 28 grams of water to give me the 30% NaOH solution by mass. Now I am adding the melted bacon fat to a container that came with my stick blender, ensuring that I transfer as much of the oil as possible. Then I add the sodium hydroxide solution, again trying to get as much of it in there as possible. To minimize the potential of the mixture to fling up the sides of my container, I tilt the stick blender to remove trapped air by the blades and set my blender to its lowest setting. Initially, I also do my best to cover the opening of the container with my hand in case the mixture still does splash up. Now I blend the mixture until it reaches trace. This is the point where the oil and sodium hydroxide solution have emulsified and will no longer separate. The mixture will also start to thicken and have the consistency of light pudding. I blended this mixture for about 6 minutes. As the mixture is left to stand, you will notice that it becomes noticeably thicker. At this point, you can put it into a mold and leave it for a day for it to solidify. I tapped the mold on the counter a few times to remove any air bubbles and to even out the surface. The next day, you can unmold your soap bar. Cue an ASMR intermission. Now it's completely solidified, and you can even cut into it to form smaller bars. At this point, you should leave it to cure for about 30 days, and what that does is that it helps to remove more water and help your bar last a little bit longer, as it won't dissolve as quickly when you use it.
Now here's the real test. I'm going to try to see if I can wash my hands from baking grease using baking soap. So you can see the grease here. Add water. And here's my baking soap. So I'm going to see if that works. It does suds pretty nicely. There you have it. My hands feel less greasy, and so we can use baking soap to remove bacon fat from hands.
This is my soap with bacon fat, and it doesn't smell like bacon at all. It basically just smells like unscented soap. And originally I didn't think I was going to use this at all. It kind of grossed me out a little bit, to be honest. But after making it and using it, I realized that it just works like any other soap, and I've started using it in my kitchen to wash my hands. I hope that you enjoyed this video, and thank you for watching.
Do 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 do.